Just like we can do operations on a vector all at once in R, so for example, if I wanted to double all the values in vector 4, I can just multiply it by 2, for example. You can also do operations on entire matrices at once, so if I wanted to take mat 2 and double all the values, that's also possible. And similarly, we can do element by element multiplication. What that means is that if I take two vectors of the same length, or if I take two matrices that have exactly the same dimensions and I multiply them together, what I'm going to obtain is a new matrix with those same dimensions where each element is the product of the two corresponding elements. So for example, let's remember what mat 1 is and what mat 2 is. If I say mat 1 times mat 2, the number in the first row, first column is the product of 1 and 100. The number in the first row, second column is the product of 3 and 3. We get 9, etc. This is really useful because data sets are matrices, and so this ability to multiply vectors or matrices that are the same length or dimensions by each other and get element by element multiplication is a really nice feature. Now, importantly, this is not the same thing as matrix multiplication. If you have done matrix multiplication before, then you know that the matrices you're multiplying have to have compatible dimensions, but matrices that have compatible dimensions for matrix multiplication don't necessarily have the same dimensions. If you want to do matrix multiplication in R, the symbol is not just this multiplication sign. If I want to do matrix multiplication to multiply mat 1 by mat 2, I have to use this symbol, percent times percent, and if I do that, I get the matrix product, which importantly is not the same as the product that I obtain when I do the element by element multiplication. If you've never heard of matrix multiplication, then you don't have to worry about it. It's certainly not something you have to do in R, but if you do want to be multiplying matrices, it can sometimes be helpful, and this is the symbol that you need to use for that. If we'd like to look at a subset of this matrix that we've called mat 3, again we use the brackets to say the word where. We want mat 3 where, and then where we're in row 2, columns 2 through 4. And if we do that, indeed we get a subset of the second row, the second, third, and fourth columns. We get the numbers 4, 6, and 8. As you're beginning to see, R thinks of objects in terms of different types of objects. And we have to worry about that sometimes when certain functions will only accept as their inputs particular types of objects. So it can be important to know whether the object you're dealing with is a vector or a matrix. An example of a situation where this matters, if I want to know the dimensions of a matrix. So if I say dim mat 3, then R can tell me that mat 3 matrix, that particular matrix, has 2 rows and 5 columns. However, if I ask for the dimensions of a vector, such as the vector I previously created called vec1, it doesn't work. I get a null value. And the reason is that a vector doesn't have dimensions, rather a vector has a length, and so that vector is of length 3. If I had asked for the length of the matrix, it would tell me the total number of elements that are in that matrix. So it's important to know whether you have a matrix or a vector, and if you're not sure, luckily R has functions that will tell you. If I say is.matrix and give it as an input mat 3, the answer is true. If I say is.matrix and give it vec1, the answer is false. If I, on the other hand, say is.vector and give it vec1, the answer is true. So I can use these functions to find out what's a vector and what's a matrix. If I have a vector and I want to think of it as a matrix with a bunch of rows with just one column, I can use as.matrix. And you can see here now that vec1, rather than looking as it did previously, just a list of the numbers 2, 2, 3, now vec1 is organized as one column in a matrix that has 3 rows and 1 column.